Our quick video here on an introduction to matrices. So we'll talk about what a matrix is, how to define it by its size, and we'll also do a few operations on scalar multiplication. So first thing, a matrix is basically just a representation of data. That data can come from a number of sources. It could be numbers that you pull from a science lab, or it could be coefficients that you pull from a system of equations. Matrices is basically things that mathematicians came up with to help them organize numbers that are a little bit confusing to deal with otherwise. And we name matrices with capital letters. So this matrix, for example, is called matrix A. Matrices have brackets around them like this, and all the stuff that's on the inside are their entries. So let's say we have a matrix that looks like this. Just pulling random numbers here, and that matrix has a size, it has dimension, and that dimension is always going to be the number of rows by the number of columns. M, for some reason, is the letter they assign to rows, N is columns. So in this case, the size of matrix A, the dimension of it, is this one. It has 2 rows and it has 4 columns. So matrix A is a 2 by 4 matrix. If we're ever asked to sort of identify specific entries, there are basically 2 ways to notate that. We would say capital A, and then in parentheses the question would call for like the specific entry you're looking for. So let's say we're looking for row 1, column 3. That entry is -8. It's in the first row and it's column 3. So row 1, column 3 is this entry right there, -8. Capital letters stand for matrices, lowercase letters stand for entries. So we can also sort of denote that by using the lowercase a 1, comma 3. That is also the same thing. Now we can come up with matrices of literally any size or any letter. So if we have matrix B and we wanted to make it a 6 by 3 matrix, that means it has 6 rows, so it's really tall, and 3 columns. Now I'm just going to fill in these numbers. They could all be the same number, they could all be 0, they can be 1s and 0s, they can be decimals, fractions, positives, negatives, any number whatsoever. They can also be algebraic expressions, a's, b's, x's, y's, all sorts of stuff. So I just need to fill in 6 rows here. I'm just going to pick numbers randomly. Make it a little bigger. Here's our second column. Here's our third column. Make this all 0s and 1s for no particular reason, and that is an example of a 6 by 3. 6 rows, 3 columns. Now if we're ever asked to multiply a matrix by a scalar, that's our next topic here. Scalar is a kind of just a fancy way of saying like a number that you would multiply a matrix by. So scalar multiplication is pretty simple. Let's say we wanted to take matrix A here and multiply it by 3. So we're taking every entry in A and sort of inflating it by a multiple of 3. So every single entry, -7 times 3 is -21. 1 times 3. -8 times 3 Negative 2 times 3. Down here we're going to go 2 times 3 is 6. 0 times 3 is 0. 33 and 0. So we just scalar multiplied, we sort of scaled up matrix A by a multiple of 3, and it changed all the entries. You can do that to any matrix. If we want to do it to matrix B, if we wanted to scalar multiply that by, let's say we wanted to take negative 1 times B, that would basically take all the entries in B and negate them. So I'll do this quickly. So it's turning all of these entries into the opposites: negative 2, positive 6, negative 7, negative 10, negative 3, 0, and so on and so forth. So that's pretty good start for matrices. Over the next couple weeks here, we're going to learn a ton of stuff on matrices. We're going to do not only the dimension and the size and the scalar multiplication, but my next video is going to be addition, subtraction, and then we'll do a video on actually how to multiply two matrices together, which is quite a bit more difficult than this. And then we'll get into determinants and inverses and identities, and then we'll probably do some application stuff where we actually start taking systems of equations and learning a new method how to solve those equations. For example, I'm not going to solve this one, but you can use matrix algebra to solve something like this. If you have a system right here and your job is to solve it, right? We know a lot of different strategies. Here I would probably use substitution. Substitution is always a good method when you have a variable there with a coefficient of 1. But let's say we didn't know how to do that, or let's say we were required to use matrix algebra to solve this. So what you would do there is you would set up a coefficient matrix. A coefficient matrix would look like this. I'm taking the coefficients of all of my terms. I'm in standard form, x's, y's, equal signs, numbers, and I'm changing that system into a matrix that has all the coefficients: negative 3, positive 5, positive 10, there's a positive 1, negative 2, negative 7. I'm turning that into a matrix. It's kind of like a little equal sign dotted line right there. You don't usually see that, but that's really kind of what it looks like. And then from there you would solve that by using some tricks, and your answer would come out from those tricks. But in any event, that's a good place to start, and my next video is going to be on addition and subtraction.